Yeah, hi all. Can I start?
Yes, sir, just give me a minute. I'll make an introduction, then you can start.
Yeah, go ahead.
Mm. Good evening, everyone. On behalf of agricultureinformation.com, I welcome Mr. Chetan Kashyap, and he will talk about high yield recirculatory aquaculture solutions. I now request the speaker to begin. Thank you.
Yeah, hi all. I am Chetan. I am one of the founder for Exflair. Today I'm going to talk about RAS. Okay, what you see on the slide, the the details of various components for a RAS. So if you look at like what exactly we do for fish farming, there are widely can be categorized at two. One is aquaculture and other is your live caught. So like you are catching fish live like from water sources like pond, river, or sea. Okay. Other is you're doing the aquaculture. You create a tank or a pond and you're doing a culture. You're growing the fish that is known as aquaculture. Okay, so in aquaculture you have various ways. You have traditional way, then you have biofloc, and you have various other ways. And then today I'm going to talk about RS. So RS is one of the very advanced technique to do aquaculture. So compared to the other, like in case of RAS, we are able to do fish farming at a very high density. So for example, in a traditional pond, if you are getting 1 kg of yield per meter cube of water, when I say meter cube means 1000 liter of water, that is known as the farming density. So in case of biofloc, typically you can get 5 to 10. At expert level, some people have even got more yield in biofloc, but traditionally they will get 5 to 10 kgs of yield. In case of RAS, you get 50 to 100 kgs, not 100 kgs, 50 to 80 kgs of yield per meter cube. So typically you are close to 80 to 100 times more yield than a traditional farming. Okay, so that is why we use RAS. Now RAS has advantage and disadvantage, which I'm going to talk about in further slides. Now, coming back to various functions, like in case of traditional farming, there is a ecosystem which is actually created by God. So like fish survives, so there are microorganisms like planktons and all which produces oxygen in water. Okay, so fish breathe through those oxygens. So for the fish to survive, they need oxygen and they also need a particular environment like the ammonia or harmful gases, pH level and all, so that they are naturally controlled in case of pond. So in case of RAS, what we do is that we filter the water. So we have a tank and then the water gets recirculated. We are pulling out the dirty water from the bottom of the tank and then filtering it. It passes through a series of filtrations and then the fresh water is returned back. And then we also add high level of oxygen using aeration and all. So what you see on the screen are the various functions of an RAS. The RAS does have a recirculation. When I say recirculation, the water keeps on rotating. Okay, so the first part, recirculating aquaculture system. Recirculating means the water is recirculating. Aquaculture is fish farming. Okay, system is system. Okay, so recirculating aquaculture system. So in this, dirty water comes out from the bottom of the tank and pumped back post filtration. Okay, so you have a now how do we filter? So typically we have high level of filtrations, which is known as a mechanical filtration. So mechanical filtration is nothing like a sieve. So for example, when you sieve your tea using a sieve, the solid particles get blocked there. So in case of RS, we use something known as a drum filter is a very common. So drum filter is something which has a it has a mechanism of auto cleaning. Okay, then there are other mechanical filter like sand filter. If we need for very high value fish and all, depending on the particle size of filtration you need, you can use sand filter, pearl filter. Pearl filter is something that we have developed. It is our original work. So pearl filter is similar to sand filter. Only thing is that it does not block. And then we have a protein skimmer, so which typically uses a mechanism of bubbles. Now post mechanical filter, you have something known as a biofilter. So in case, so mechanical filter typically depending on what you use, in case if you use drum filter of let's say 40 to 50 micron, 80% of the excreta fish, when I say fish excreta, they will get cleared by the mechanical filtration. Now, 20%, which are smaller particles, like let's say smaller than 40 microns, are soluble, like urines are soluble. So they pass through the drum filter. So they also need to be broken down. To break that, we use bacteria. Okay, so that is known as a biofilter. Okay, these are another two primary functions of RAS. So biofilter, you typically have MBBR, which are known as moving bed bioreactor, and then fixed bed. Fixed bed typically we use ceramic media. And then we have various other biofilter. You can, for academics, you can actually Google and find out, but typically we use terracotta and overburned bricks. Okay, these are the primary things. We also use mechanical traps, which are nothing but a PU foams. So the things that I'm trying to tell you is that we actually use in our systems, which are practically possible. Okay. Now, the other things that during the process of that ammonia, like once the excreta, urine, they start getting broken down into various particles, there are various gases that get produced. Some are very deadly, like small traces of it can kill your whole culture. Like H2H gas is a very deadly gas. Okay, so we also have to remove those gases. So for removing those gases, we use a trickling filter. In case of a trickling filter, the water trickles down and then it removes. So flour media, activated charcoal. We don't use activated charcoal. And the other way is that very high level of agitation. So very commonly we use high level of agitation, which are very practically, and then we use trickling filters or flour media. So these are two we use in our systems. When I say agitation, if you give a very high level of aeration or you do a airlift, then you typically get rid of your gases. Okay, then you have other function which is disinfectants. So disinfectants typically removes pathogens from the system. So there are various ways to remove it. There is a biotechnology. So we have developed our own biotechnology, like formulations, which is very effective in controlling the bacteria and all. On top of that, we also use ozone. We use UV in some cases we have in some series, but primarily we use ozone and biotechnology to control the bacteria. Now, then we have another important functions, which is an aeration. So aeration, we have to add oxygen, right? Because fish will keep on consuming oxygen, so we have to continuously supply oxygen. So there are various ways to supply oxygen. So common ways are blowers. Blowers can be diaphragm pumps, ring blower, root blower. They have a different applications. And then for advanced, like if we need a very high level or if there are saturations very high, or for we also have oxygen generators. Oxygen generators are very costly. So we use it at limited applications. For example, in case of a drought, or in some countries like we have designed for, like if it is a foreign country like Kuwait, Oman, so they have a very high temperature and very high humidity. So the humidity is very high, temperature is high, the blowers and all are not very effective. So in those cases we have to use oxygen generator as a backup. Okay, I'm moving to the next slide. Okay, now coming back, there are various water parameters that I spoke about that we need to maintain. Now, these are all for academics. These slides I will share so you can go through it. So typically we have a pH. This is a very wide range, but most of the fish requires a pH of 7.5 to 8. We can control the pH in case if we have a pH problem. We can control by adding, like if the pH is high, it means it is alkaline. If the pH is low, it means acidic. If it is acidic, then we have to add like quicklime. If it is alkaline, we have to add tamarind. Or there is also some, if in case if in one cases in one of the sets we have to use citric acid to control the pH because it was very high. Like the pH was very high, it was very difficult to control. Or in case if it is still not getting control, then you have to use some pre-filters to see there are some root causes why it is getting high. The pH, in case of you're not able to control using this, then you have to use some pre-filters to filter out the unwanted chemicals that might be affecting the pH. Okay, the DO is another very important parameter. The good thing is that you don't have to monitor DO. Once you set your aeration to a certain limit, the DO does not fluctuate unless and until there is too much of temperature variance or the air is saturated. If very high level of humidity or the temperature difference can affect your DO, that you need to take in mind. Otherwise, you don't have to constantly, if your aerators or whatever you have put systems are working properly, the DO typically remains constant. Okay, some fish like trouts and all, they need very high level of DO. So for them, we typically maintain, you need to maintain a DO of very 8 and above. Okay, TDS is another important parameters. Typically TDS, EC and all you maintain using raw salt. Okay. Now these are the two important. The ammonia is something that you have to, that keeps on varying. And if the ammonia and the pH has a kill zone, so if in case if the ammonia, so if the pH is high, a very small trace of ammonia can kill your fish. So you have to closely monitor your ammonia. In case if your pH is high, then you have to be very aware that you have to keep your ammonia at the lowest level. Okay. NO2 another typically is a like a measure of how active the biofilter is. So you have to periodically measure these parameters. Okay, now coming back, so this is like we started some my partner actually started some 20 years back. So this is the first system that we built. So this you can see it's a very basic RA system. So here you have a tank, and then these are very basic filters. Okay, the water is coming down from the bottom, and then it is going through a series of biofilter. It is coming back, and then you have variations in that. Now these are some of our advanced RAS systems that you can see. Okay, here like for example, these are the circular ones. You can see these are all tanks. Okay, and then these are all series of filtration. All this inside. So water gets, the dirty water comes here, it goes through the series of filtration, it gets back. And then you have, typically we have IoT devices also which automatically measures the pH. So it comes in your mobile device. Okay, based on that you can take actions. Okay, now this this I am explaining through a diagram. Okay, so that it is sort of whatever I spoke earlier, I'm revising through a visual diagram so that it is easy to understand. So in case of an array, so this is a fish tank. Okay, and then you have this central pipe. Here you have small holes. Okay, so the water will enter through these small holes. It will come through this to the drum filter. Okay, here it will get filtered and then it will go through the biofilter. It will go through a series of biofilter, and then here from the green pumps that you see, it is a return line. So here the water is coming back, filter water. This is optional in case if you require high level of like very fine clear water, then you can use like sand filter which will clear water, like which will make the water almost crystal clear. For most of the fishes, common fish, you don't need to put sand filter. They don't require crystal clear water. A normal clear water is enough for them as long as the ammonia and other parameters are maintained. A mixing capsule typically like all, so when we add ozone, it has to mix in water. So here we mix it, and then here the water comes back. Here what you see, these are known as diffusers. These are micro bubbles through which you can pump oxygen in these systems. Okay, this is the earlier one that I spoke about is a single tank. Here you see a lot more complex system. Okay, so this pool is nothing but your tank. So the water is coming through a drum filter, and then it is going through various level of biofilter process. This is nothing but a trickling filter. Trickling filter I spoke about for degasifications. So this is holding tank. From here the water gets pumped. Here you have a protein skimmer. Here you have oxygen concentrators. Then a mixing cone and the water comes back. The blue line that you see, these are all aeration lines. Now all this goes and gets monitored. So this is a control panel. So this or you can switch it into automatic mode or manual mode. So in case if it is an automatic mode, you don't have to do anything. It will automatically it will on and off based on the timer settings or based on certain controls. You can also set controls. For example, if there is an event such, do this. So all those things that you can computerize, you can write a program to run it accordingly. Okay, now we also have live fish transport systems, like to carry live fish. So this is actually what an RS, complex RS looks like. So on the right corner, you can see this is submersible filter. This is a live fish transport systems. This is an RS. This is your control panel. So all this data gets fed into something known as a farm grid. Okay, here you can, let's say there are hundreds of site, BLR01, BLR02, HYD01. So from a single grid you can monitor. All this data is getting pumped through IoT Wi-Fi. Okay, you can see the real time, and then you can monitor all these parameters. If there is an alert in certain sites, you can drill down and check, and you can monitor if your RAS is working fine or not. These are the links. So you can find a lot of catalogs, product pictures, videos here. Okay, in case if you have more queries and all, you can anytime reach out to us. We'll be very happy to help. And that is me. So this brief introduction. I'm the director for operations. Prajol is one of the head scientists. And then we have Akash, and then we have Babita. Okay. A lot of people ask why RA. So this is a market scope. So it's a very big market. So in case if you, like, a lot of people say why I don't invest in farms. So RS has its own limitation. It has its own advantage. Okay. So yeah, I'm not telling RS is the like solution for everything. So there are things where traditional ponds are better than RS. Like there are some fish we cannot do in RS. Okay, but if you look at a competitive advantage, this is how the RS look like. It typically 100 times more yield than a traditional farming. Okay, and just building a normal RS is not enough. So you have to build an RS which is efficient, which consumes less electricity, where you consume less resources and all. So this is actually a comparison of how the RS system, like, so typically if you compare with the foreign systems, the RS has our, like, typically if you, when I say compare, means we compare by yield. So for 1 ton of yield, what is the cost of our system? So when you do all those comparison, we consume like say 50% more resources. Now to set up a efficient RS, you have to worry about every kilowatt or every HP of power that you spend. So so for that, we typically, if you look at our earlier slides, we have used biotechnology. So we have used biotechnology. So that helps us in making the system cheaper and a lot more resource effective. When I say cheaper and resource effective, because biotechnology in along with RS, like we typically convert the whole RS into a cleaning bacteria pool. So that helps in more resource utilization, and typically we consume 50% less resource. Okay, these are some of the systems that you can see the RS. So there is nothing like a one system that works for all. So we typically have a P series and then an AF series. So typically when I say P series, based on the type of fish, when you design an RS, it is important to understand the customer requirement. So for example, if you're doing common fish, you should not use very powerful, because if you're doing a common fish, you should use a system which is cost effective, which consumes less power and less resource. So we typically have designed a system which does not have a lot of costly components like protein skimmer, then sand filter. We don't need sand filter for if you're doing a normal pangasius or like a common fish. We don't need sand filter. Okay. So why to put expensive machines, protein skimmer, UV? You don't need all those because they consume powers. So you have to be very cautious when you try to design an RS. Okay, so that's why we have broken into multiple. Now again, there is another category which is shrimps. So they have a very different requirements. You have to so based on the type of fish that you do, you have to adjust your flow rate and you have to adjust how the system works. Okay, these are various risks typically that you have to manage when you are doing an RS. So you have to look at disease. So in case of so disease and all are you cannot eliminate it 100%. So what you typically do is that you have to maintain a very high level of biosafety procedures when you are doing an RS. Yeah, this is a very good comparison. So which I had spoken earlier. Here you can see it in a visual format. So there is what I have done is investment in per ton. In case if you are doing a traditional pond, conventional biofloc. When I say high-end RS, typically high-end RS are your imported systems. Imported systems do work, but they a lot of time they become like a white elephant, which is very difficult to maintain, and they are so costly that you never break even. So you have to be cautious. I'm not telling all the systems are like that, but most of the systems, people when they take a decision, you have to think about all this. Okay, so traditional pond typically, if you look at our RS and all, they we have optimized it so that the per ton investment is the lowest. The run cost, if you look at our run cost, we have optimized to a level of a traditional pond. Okay. So these are the very like when you try to design an RS, you have to look at all these parameters. What is your investment? What is your run cost? What is your mortality risk factor? Okay, it is not just design an RS and then like I have seen people designing an RS. Like our RS is consuming 10 kilowatt, their RS is consuming 50 kilowatt, 5 times more. So the cost of electricity is 50 rupees per kg of fish produced. So ours is 5 rupees. So if you are consuming 50 rupees to produce fish, then it is not going to be cost effective. You are not never going to be making profit. So when you design an RS, these are the challenges that you need to look into it. Yeah, that's all from my side.
Okay. Thank you very much, sir, for your presentation. I will take up the questions now. In the meantime, can you please stop sharing the screen, sir?
1 minute.
Yes, sir. I'll move on to the questions now. The first question is, which fish species are most suitable for high yield RA systems in Indian conditions?
Yeah, I also I can answer that question. I also have my partner Prajol. He is also a scientist. I'm going to talk about it, and you can also unmute Prajol so that he can add on. Okay, so it is a very vast topic. It depends from region to region, country to country. So I will take an example of India. Okay, in case if you are doing RS in a cold area, for example, let's say Kashmir, Himachal. Okay, so you have an option to do cold fish like rainbow trout. Rainbow trout is very popular in Kashmir. Okay, in case there are fish which are common which has to survive above like they require a temperature of 22 degree. They can some may survive in 15 degrees temperature also, but they will not grow. So you cannot do all those fish in Kashmir. So in general area like let's say where you have a moderate temperature, when I say moderate temperature, the fluctuations may vary from 10 degree to let's say 50, 45 degrees. So you can manage it. When you say manages, if the 45 degrees, you can put green shade and also the water temperature need to be will be maintained below 33, 32 degrees. Okay. So the common fish that you can typically do is all type of like you have tilapia is a very easy fish to do. Then you have catfish. In the catfish, you have singi, desi magur, papda, then koi, tingla. So these all grow very well in RAS. This grass carps and all we have at least we don't have a very good experience in growing them in RAS. They typically require soil Okay, we have not been successful. If there are people who are successful, I don't know, but we have tried. Especially like common carp, we were able to grow in RAS pretty well. But when it comes to rohu katla, they don't grow very well. So they beyond a size, they take very lot of time to grow. Okay, and then we have other fish like high value fish, like you have marl, like snakehead marl. Then we have rainbow trouts. We have sea bass. All these things they grow well. With that, I will pass on to Prajul in case if you want to add anything. Prajul, you're there?
Yes, yes.
Yes, sir. You can
Yeah,
proceed, sir.
actually, Chetan has covered this topic. Now, thing is that personally, I believe if you have a good market, based on your market, you can decide which fish is suitable for RAS. Technically, you can do any fish in RAS if the seeds and the water parameters are maintained. But we have to look into the commercial part and as well as the demand in the market for that particular fish. For example, if you are in Bengal, in West Bengal, and if you are doing Singi, then it is very much suitable to do in RAS, even in small quantity or in low density, because the price is very high. But similarly, if you do it somewhere else where the demand is not there or the price is not there, then it is not suitable. So mostly it based on the market and the climate, obviously. But in sophisticated areas, even if you want to do climate control, like if you want to bring down the temperature, if you have budget, then you can definitely go for different fishes in different region as well. For example, there is a huge demand of caviar in international market. Even if we do in India, we can export it 100%. But the problem is that it required a lot of investment. Caviar farming is not very easy, and it's required extremely cold temperature. But in foreign countries, especially in European countries, they are doing caviar 100% in RAS. Also, I've been to Dubai. I have a chance to visit a RAS farm over there. It was strictly no video or no recording, no photography zone, so we could not take anything from there. Only we could see it, and it was belongs to the royal family, and they are doing breeding and as well as growing of salmon. You know, the salmon fish, the orange color salmon fish. I think it's American fish, and they are doing successfully. So thing is that and local consumption is there, and also they are exporting the seeds from Dubai. But Dubai climate doesn't, supports salmon culture. But they are doing it absolutely in optimization because salmon is a migratory fish. Sometimes in their life cycle, they need salt water, basically for grow, and for spawning, they need fresh water, and also high flow rate is required. So many technical things are required. So my point is, if there is a demand or there is a plan, then technically we can do a lot of new fishes in RAs. If you consider like even hilsha, breeding of hilsha or breeding of some other fishes like marine fishes which have demand in domestic and as well as international market and high value fishes, we can definitely consider RAS because that is the only option we have. In normal ponds or natural farming, it is not possible. So that's all from my side.
Okay, I'll move on to the next question, sir. What is the approximate initial investment required to set up a small to medium scale RAS unit?
Over to Chetan.
Yeah, I don't know about the other manufacturers. So our RAS, we have developed like the lowest one was 2 lakhs rupees. That we have developed for marginal farmers. Like other than marginal, like when I say marginal farm, not necessarily like for small villages who will do the culture themselves. But our otherwise our RS price starts from 12 lakhs rupees. Okay, the smallest one. A good medium size will start from when it's 25 lakhs rupees. When I say 25 lakhs rupees, like it will come with machinery tanks and all. On top of that, there will be some civil work that they have to invest. There is no upper limit, like a decent size large one RS will cost around 60 lakhs, 70 lakhs. It can go in crores. There is no upper limit.
Okay. And how long does it typically take for farmers to achieve return on investment in RAS farming?
Okay, like the earliest they can achieve is if they are doing, like there are some farmers which they grow seeds. They will buy very small seeds and they will grow for 45 days, they will sell it. Okay, in case if they do that, they can get return on investment in 45 to 60 days. Okay. There is other thing that I have missed out in my earlier answer. So we can also do shrimps, we can also do crabs. Okay. So if you do shrimps, typically shrimp you can harvest, earliest harvest is 45 days, 45 days, 60 days, 90 days. These are shrimps. Okay, so you can start getting your returns after 3 months, let's say 2 to 3 months. Okay, in case you do shrimps. But otherwise, in case of tilapia also you can get it faster. But unfortunately, tilapia price is very low in Indian market. Is most of the time it is not economically viable to do in RS because it is not profitable. So other than that, typically takes 6 months for most of the other fish in RAS.
Okay. What are the common mistakes beginners make while installing or operating RAS systems?
Yeah, one of the most common thing that, so a lot of people, they watch a few YouTube videos and they try to do RS by themselves. Okay, so it is like a kill zone. It is RS is, though it looks straightforward, it is not easy. Okay, so you have to synchronize the system. Like your body has, like it, your heart beats at a particular rate, blood flows at a particular rate. So it is not as complex of a human body, but you have to synchronize your RS. Okay, and then it is not only about synchronizing your RS, it is about also about like it has to be profitable. Like for example, if you make a hi-fi RS and do tilapia sells for 80 rupees, you hardly make any profit. So you have to look at the four pillars when you look into RS. One is your system, other is your input. Input is what you put in your system, your seed feed, and then third is your process. Process is how process and practice, how you follow, like biosafety. Okay, and then the final is your sale. So a lot of people actually fail in sales. Okay, they don't make a judgment when they try to decide. So these are the four keys. Most of the people fail at the system level. They're not able to design RS properly. Okay, if they try to do, but a lot of people fail at the sale level too. Okay, sale. A lot of people are not able to sell. Then they fail in RS.
Okay. What kind of training or technical support is required to manage a RAS system efficiently?
Again, I can answer for me. So our RS, like large RS, requires 2 to 3 people. It is very easy. It's all automated. So there are various standard operating procedures, like machines and all. They will start on and off automatically. Someone need to monitor, like even the machines are automatic. Someone need to monitor if they're on or off. So typically you need a 24 hours round the clock monitoring. If it is a large RS, when I say like let's say 2 crore project, so typically you require 4 people. If it is a small RS, minimum you require 2 people to monitor. Okay, but otherwise it is pretty straightforward, very easy to manage.
Okay, thank you very much, sir. We have now completed the round of questions. On behalf of agricultureinformation.com, we would like to thank Mr. Chetan Kashyap and Mr. Prajwal Ghosh for the talk and for answering the questions. This meeting will now be closed.
Okay, thanks.
Most welcome.
Thank you.
Welcome, sir.